we're all set on 1 through 12. Okay, what about 13 through 24? Any on 13 through 24 cause you problems?
Only 23 and 24.
Only 23 and 24. So what would you do on those? All it does, since you didn't know the notation, you can look it up and figure it out. But if you didn't, we'll just do it now. It's fine. All that means, ln 4 equals x is the same as log base e of 4 is equal to x. So what did they ask you to do? Just translate this into a exponential form. So that's e to the is equal to. That's it. So what's this one? E to the equals x. In this case, we just solve that. So what does x equal? E to the 4th power. One step. Translating is commonly your last step.
So ln is always
Log base e. Always. It just means natural logarithm. Here's a side note about ln. Remember how I told you in the remember the change of base formula from yesterday? It was kind of important. It allowed you to change bases, which would be very, very important. You could arbitrarily choose what bases you wanted. Sometimes we chose base 6, but what was our base that we really liked? We liked base 10 or base e. Now, sometimes if base e or base 10, either one is totally fine. You generally see base e chosen more often. Why? And it's a really simple answer. What? It has nothing to do with the math.
This is one letter less.
It's one letter less. That's what I believe. I've looked at books. Some books arbitrarily will use log base e way more than log base 10, and I'm pretty sure it's just because it's 2 letters. What I've also heard in other countries, when they, instead of writing log without a base, when it's base 10, they just go LG, right? You do that? Yeah, I've seen that before. LG is, that kind of makes sense. LG means log base 10. LOG, you have to put the base in. I like that. It's more logical, but Americans, we don't really prove ourselves to be logical that often. No, and the Germans finds it funny. That's right. Okay, anything else from... that's not what I wanted. Anything else from 13 through 24?
Can the base be negative?
Can the base be negative? So, for example, can you have log base negative 2 of x equals 18? Something like that, right?
You can. Wait, no.
Well, look, all that means is x is equal to negative 2 to the...
However, it depends on
That's a really close to 0, right? It really depends on the question. In general, though, Victor, no. I will never give you bases with negatives. Generally speaking, you run into big problems, and the general answer is no. Mathematically speaking, was this allowed?
Yes.
Kinda? Yeah? Just avoid it. We're not going to run into that, okay? That's a very good question.
See if the power is even or odd.
Exactly. Really careful.
Yeah.
Really careful. Okay. Anything else on these? On, 13 through 24? Okay. 25 through 36.
This last one.
Without using a calculator. Without using a calculator. You have to use exponents. You have to simplify these. So which one do you want to do?
we do 13.
We have a bid for 32? That's a good bid. I like that. So for 32, what do you think a good first step is for 32?
Change the.
Yeah, change. I'm hearing the same thing in a few places. That's good. Change it to what? Log base 5 of what? 25 to the 1/3? That's what I would do first. Correct? What can you do with that 1/3 now? Put it in the front. It's 1/3 log base 5 of. This is something we did talk about yesterday, but you're going to have to do this over and over again. When you see 25, what do you automatically need to think about? 5 what? Squared. You automatically need to recognize powers. So what does that actually equal? That's 1/3 of log base 5 of 5 squared. What can you do with that 2? So it's 2/3 log base 5 of 5. What is log base 5 of 5? 1. So what does this equal? 2/3. Log base a of a is always equal to 1 because a to the first is equal to a.
Is it a rule that if the power, if there's a power that for the number of that 2, you can present the power?
Yes, or you can take the 2/3 and put it back up if you want to. Sometimes you need to go back up, sometimes you need to go to the front.
Is it any?
Yes, we talked about it yesterday, yep.
How does it become a cube root one multiplied by
One of the log rules is this. A log of b is equal to log of b to the a power. You can move that a either place. You can move it up, or you can move it down. They're the same.
It can be explained.
Oh, I'm sorry, what?
I mean, how do you know that cube root of 25 is 25 to the 103? Is it like if it's
How do you prove it? So basically, how do you prove it? Hold on, Justin. Let me prove it for you. Hold on. I'll do a mini proof for it. That's a valid question. So for example, you asked this: the square root of, let's say, the square root of x is equal to x to some power. Let's say you didn't know what the power was, right? Right? How do you get rid of a square root? What do you want to do to both sides? Let's square both sides. So when you square the square root of x, what do you end up with? X. And when you have powers of powers, what do you do with those two numbers? Multiply them. So that's x to the 2 question mark. What's the power of x on the left? 1. Do you agree? If x to the first equals x to the 2 question mark, what has to be true? 1 has to equal what? 2 question mark. So what does question mark equal? 1/2. So what did we just prove? The square root of x is what? X to the 1/2. You can do the same thing for cube root. The cube root of x is equal to x to some power p. How do you get rid of cube root? You cube both sides, so it's x to the what power? 3p. It works for, x to the, yes. You can use similar logic for all of them, yes. So what does p equal? 1/3. So the cube root of x is equal to x to the 1/3. Just an exponent rule. We're learning this all in pieces. That's fine. Yes?
Is it, go down a little bit.
Yep, tell me when to stop.
Yep, just that. Oh, wait.
Yeah.
Go up a little bit. That rules?
Yeah.
Is it can be explained logically?
Yeah, for now. Let's learn the rules. The rules, the basis for the rules for precalculus is they are consequences of each other. You use each of the rules to prove the other ones. For example, let's say you had log a plus log a plus log a. How many log a's do you have? So you have 3 log a, correct? Correct?
Yeah.
What I'm telling you that's equal to log of a to the 3rd. Another way to think about that is this. When you have 2 logs and you add them together, what do you do with what's inside? You multiply. So what's log a plus log a? Log a squared, and then you have plus log a. What do you do now? Log a cubed. You see? They all interrelate to each other.
Still cannot explain any only precalculus.
Essentially, yes. Essentially. It's a closed set. The rules, these are rules, they are consequences of each other. None of the rules violate each other, they support each other. For example, division, think about it this way. You ready? I told you this. Log of a minus log of b is equal to what? Log of a over b, right?
Yeah.
Well, now you know this is the same as log of a plus log of b to what power? -1, right? You could take that negative sign and bring it up there, right? Correct? Are we okay with that?
Yeah.
Now you have plus, so what do you have to do? You have to multiply, right? So that's log of a times what? Which is equal to log of a over, you see? They're all interrelated.
But you have to use the basic rules to support others.
Yes, that's correct. It's a closed set. We're defining a new field for you. This is a new field.
But the basics still cannot explain.
Well, not outside the field, but you can't always get that. Like, okay, think of what I mean by that is this. Think of a word. Got it? Think of the definition of that word. What do you have to use to define that word? Other what? So you have to define those words, right? What do you define those words with?
Another word.
Language is a closed set. You use words to describe words. That is our definition of words, right? The same thing goes for math. It depends on how far you want to go. So basically, can you link logarithms to other things? Sure. You can translate them to exponents. It depends on what kind of proof you want and what your definition for a proof is. This is a closed set of rules. They support each other. They work with each other. They don't violate each other. Okay, let's go back to the PDF here. Any other ones on 25 through 36? Any other ones? 34? Sure. So on 34. So, do you know what that equals? No, you don't. What form is that in? Log form. So let's translate it into. So can someone translate that? And let's not use question mark. It's hard to write question mark. What letter do we want to use? Can someone tell me what this is in exponential form? Root 3 equals. Good. When you see 9, what should you think?
3 squared.
When you see square root of 3, what should you think? 3 to the 1/2. When you have power of powers, what do you do with the powers?
Times together.
So it's 3 to the what power?
X divided by 2.
If 3 to the x over 2 equals 3 to the 2, what has to be true?
X equals 4.
All done.
Wait, you can also use the rules of the logarithm.
You can use anything you want. Absolutely. Yes, absolutely. Just be careful. This right here, this is the way I would do it. I like this. This is clean. I like this a whole lot. You have to be really careful if you put it to the front because you have base of root 3, so you'd have to have base root 3. Just be careful, okay? Are there lots of different ways to do these? Absolutely. Can you make them as hard as you want to make them? Yeah. This is I like this one because it's middle of the road. It's not like the shortest number of steps, but it's really clear what's going on. If you don't know what it equals, what should you do? Equals, I don't know, equals x. Start there. We are allowed to translate this from log form to exponential form because, why?
They didn't validate.
There's no coefficient. If there was a coefficient, you'd have to move it up first.
Move it into
The power. Okay. Any others on 25 through 36?
how about 35 and 36?
Okay, those take. Let's do one of them. ln of e to the third. Oh, you can do that one. ln e to the third, right? That's log base e of e to the third. That's 3 log base e of e, which is 3. All done. ln of e is what? 1. Have you done this in the past in your math work? Written the number 1 in fancy ways? Yeah, you do it all the time in algebra, right? You multiply by 1 because it's the multiplicative identity. When you multiply by 1, are you changing the value? No. So are there other ways to write 1? Absolutely. Log base a of a, ln e, they're all the same thing. 1. Yes?
You get 3 because you move that cube up.
Yes. And then this right here is 1. It's 1.
It was like
Like another way to prove that for you? Like here's a couple ways. Log base a of a is equal to log of a over log of a, which is 1, right? Log base a of a is equal to question mark, right? So therefore a to the question mark is equal to a to the first. So question mark is equal to
I like that.
1. There's different ways to go about it. One last identity that comes up, and we need to prove it out. It's not an identity, but I guess you could call it an identity. A to the log base a of x. What the heck does that equal? It looks really super complicated, right? Correct?
Yeah.
Is that log form or exponent form?
Exponent.
It is exponent form. It has a log in the exponent, but that is exponent form. Can someone raise their hand and tell me, one person tell me, what is that written in log form? Yes.
Log a base a
Of r is equal to
log base a
of x. Yes, because this right here, I'll use a different color. This right here, where did that go? Right here. The r went right there, and we turned it into log form. And this a right here, where did that a go? Right there. So here's the thing. If log base a of r equals log base a of x, what has to be true?
R equals x.
Yep. So what does that mean? We just showed everybody a to the log base a of x is always equal to x. So for example, 7 to the log base 7 of q, what's that equal to? Q. Does it matter if the 7 gets changed? No, as long as the 7s are the same, it's always going to be
So if
Q.
both bases are the same.
Yep. It's going to be Q. That's something you will run into. I can get on the sheet. There's a few of them. You're going to look at like, I don't know. Oh, wait. When you get these right, it'll feel correct. That being said, some of the answers will be Kind of ugly. Okay, let's move on to the last phase here. What about the last 37 through 44? Stop at 36. Good, because I do not want you to do this. Okay. Has an answer for number 1. Who has an answer? Let's raise your hands. Whose hands here? I'll call on you. Don't say it out loud. Let's go with Justin. Go. What's the answer? X equals?
Equals 3.5.
Who got 3.5? Yay, you're popular today. Who has number 2? Who has number 2? Olivia.
X equals 3 and 2/3.
How much?
3 and 2/3.
3 and 2/3? I hate fractions like that, so what's a better way to say that?
11/3.
Yeah, there you go. 3.5 is okay. I'd rather you see what? Yeah. Who agrees with 11/3? Ah, you're popular. Excellent. What about number 3? Number 3. Let's go with Stan. What? X equals 2√2. Who got 2√2? One other person, so you got a friend over there. Let's just do a verification of that. So for number 3, you have log base 3 of x squared plus 1 is equal to 2. So 3 squared is equal to? So x squared is equal to? So x is equal to? Plus or minus the square root of 8, which is equal to?
Plus or minus
2√2. So how many people got root 8? So both of you guys were almost there. It's the proper answer would be plus or minus 2√2. Cool? Yeah.
We put plus or minus root 8, then it sometimes it's not finished. Like,
That would be okay. I would like, I mean, it'd be neat if you did 2√2. Who got number 4? Who got number 4? Baldwin. What? What? 20.75? Who agrees with that? No? Who has a different answer? Let's see if we have a consensus on something. Yeah, Victor.
4.1.
What?
4.109.
4.109? Who used your calculator? You don't need a calculator for these.
Huh?
So, let's do number 4. That's 5 squared is equal to? Maybe you need your I didn't think you did, but maybe you do. So 0 is equal to?
X squared plus x minus 24.
Ah, so Victor, you are right. I hate decimals. I love exact answers written in improper fraction form. So what do you have? What did you use to solve this? Yeah, use the quadratic formula. Don't punch it into your calculator. Just give me the radical answer, okay? So b squared minus 4ac. 1 squared minus 4 times 1 times negative 21. So that's equal to 1 plus what? Which is 85. So x is equal to negative 1 plus or minus the square root of? All over 2. Is there anything you can do to simplify that? What are the factors of 85? 5 and 17. Are those powers of anything? No. So can you pull 17? Is like not really. Not so much.
Make it 25 equals x squared plus x squared minus 12 minus
How?
9.
This is a quadratic.
So we can't solve that algebraically.
This is solving it algebraically.
Oh.
Okay, so we have x equals negative 1 plus or minus the square root of 85 all over what? 2. Nice. Okay. What about 5? Who has an answer to 5? 5. Someone who hasn't spoken. Denise, what do you get? Who got 16? Who got 16? You're popular. Yay! And what about 6? We'll come back to any questions. Who has an answer to 6? Hanley. 1 over 3. Who got x equals 1 over 3? Who got that? You have a friend over there? 1 over 3? Did someone get a different answer for number 6? What did you get, Olivia? You got 3? Let's test out number 6. So I'll do this nice and tiny right here. So that's log base 4 of x to the negative 2 is equal to log base 4 of, what's 9?
3 squared.
3 squared. So you have x to the negative 2 is equal to 3 squared. Now, you could turn this into a fraction and cross multiply, or you could do the most direct thing, which is you need to turn that negative 2 into what power?
2.
What power do What power do you want that negative 2 to become? 1.
Positive. Well,
You just want 1 because you want it to be x, right? What power do you raise both sides to? Because what happens when you multiply these now? X to the equals 3 to what power? Which equals 1 over 3. So it is 1 over 3. There's another way. I'll do the longer way. I'll do that one out there. So what was the original question? It was negative 2 times log base 4 of what? X equals log base 3 of what? 9. Is that correct? Base what? 4. That's a different question, yes. So how did you do it? What did you do first, Olivia?
First, I moved the negative 2, I changed the negative 2 into an x,
Yep.
and then changed 9 into 3 squared,
Good. Okay, sure.
and then I moved both of the exponents back, so it was 2 log 4 of 3, and, oh, never mind, I see what I wanted.
So you did 2 log 4 of 3.
Yeah, and then negative 2 log 4 of x.
Negative 2 log 4 of x, yeah?
I left out the negative 1.
The negative 1, that's the only thing you missed. And that would change it from 3 to 1/3 if it was 3 to the first or 3 to the negative 1. Good. I'm glad you found it. Okay. So that's the first 6. You feeling warmed up here?
Yeah.
Are you ready to conquer some more?
Wait.
Yeah. What's your question, Justin?
It's the number 5 question.
Yeah.
So there, because I put the coefficient into the logarithm.
1/2 log base 3 of x equals what?
2 log
Base 3 of 2.
2.
2 log base 3 of 2. So what did you do first?
I put a coefficient into the logarithm.
So it's log base 3 of the square root of x is equal to log base 3 of 4.
4.
So therefore the
So-
square root of x is equal to 4.
Oh, you can do that.
So x is equal to? Are you dividing the log to get from there to there? Please say no. You're not dividing. You just know. This is a rule you know. If log A equals log B, then what? A equals B. You know that, right? Why is that important? Because some people might do this, like log of A over log of B. They might think that's equal to what? A over B. Is that correct? Gosh, no. Please don't do that. Please don't do that. You can't cancel. Like, can you do this? Sine of pi over sine of 2. Does that equal pi over 2? No. 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 Try to get a nauseous Pavlovian response out of you. Okay, you clean your rooms. Okay, you like numbers 1 through 6? Let's keep moving.